This lesson is on how to find domain algebraically and a little bit of a review with domain and range interval notation. So this will be looking specifically at two types of functions when there's a square root or a cube root or any kind of radical in the function, or when there are variables in the denominator. And that has a special name. Those are called rational functions. So here's the first example. I'm going to let you try and solve it and see if you can get the answer. We talked about this a little bit last class. So the problem with this is, because we're looking at the real number system, we cannot have a negative number under the square root. So what we have to ensure is that for any value of x, my output, my range, will be larger than or equal to 0. Because there's nothing added here, we're just going to take the square root. You can take the square root of 0, but not a negative number. So to solve for the domain, we just take everything under the radical and then create an inequality where this has to be larger than or equal to 0. And when you solve an inequality, it's very similar to solving as if this were an equal sign. So we're just going to subtract 6 from both sides. And subtraction's okay. The really important difference is if you multiply or divide by a negative number. And we'll talk about that next example. But here, to solve for x, we don't divide by a negative number. We divide by a positive 2, so we don't have to worry about flipping the sign. And the domain is all values for x that are larger than or equal to -3. And you can just check that. So what happens if you put in -3? Well, 2 times -3 plus 6. This would be -6 plus 6 equals the square root of 0. Perfect. So you can either write it, you can leave it like this, or if you want to write it in interval notation. And when you write interval notation, always write the word domain. Here we know it's domain because there's an x, but interval notation doesn't use a variable. So our minimum value is -3, and it includes -3, so we make a blocky parenthesis. That's the minimum. And the maximum, well, there is no maximum. You can put in as big a value for x as you want. So we have infinity, and then we use a curved parenthesis because you don't include infinity. You never can reach infinity. It's not a finite spot. Did you get that? I hope so. Next one. Oh, sorry. Here's the graph. So here indeed is 1 to -3. And then there's no arrow here because I used Desmos, but there should be. And just like we said before, we said earlier, the domain is -3 to infinity. And what about the range? Well, for this kind of problem, it's easier just to look at the graph. I mean, you can use common sense and say, well, the smallest that this can be is 0, and I don't have anything added or subtracted to it, so I know that the smallest it's going to be is 0. But you can just look at the graph, and we're taking, if we grab onto this line, there's no red function here, here, or here. It starts here. Oops, it's not quite straight line, sorry. And then as you go up, the blue, supposedly horizontal line is crossing that pink curve. And even though it goes above it here, this goes on forever. So the range is, the smallest value you're going to get is, oopsie, is 0, and it includes 0, and there is no maximum value. If you put in a billion, you can take the square root of 2,000,000,006. You can put in a quadrillion. You can keep going. You can make x bigger and bigger and bigger, and then y will get bigger and bigger and bigger. Okay? So here's our next example. So that's the same principle. We have a square root, and under here, this must be larger than or equal to 0, or else we'll get a non-real answer. But in this case, you have to be careful because to solve for x, we may have to divide by a negative number. So one way to avoid that is just to add x to both sides. And then you get 3 is larger than or equal to a positive x. Or if you can just flip it, the little pointy side is pointing to the x, so you can do x. And like this, these two are equal things. So you can say 3 is larger than or equal to x, or x is less than or equal to 3. They're the same. They're equal statements. But now, what if you didn't add x to both sides, and let's say you solved this by doing kind of what's traditional is to get the constant on the opposite side of the inequality, and then you got negative x is greater than or equal to negative 3. Now to solve this, you have to multiply both sides by a negative 1. And when you do that, you have to switch the sign. So really, really, really pay attention to this. You have to flip the sign. This is going to go this way. And then you notice that it's exactly the same as this. If you don't flip the sign, you get the opposite answer. So it's kind of a weird quirk that you have to do that. Why? Because if x is 100, x is larger than 3, but negative 100 is not larger than negative 3. So you have to, you'll get the wrong side of the solutions. Like here, if x is 100, you're going to get a negative under the square root, and you don't want that. So that is for the domain. And let's look at the graph here. Yep, just like we talked about, 1, 2, 3, here's 3. It can be 3, and then it goes on infinitely to the left. So the domain is, like we said before, the smallest value, there's no min value, but the max value for x as we go this way. The largest value of x we get is 3, and it includes 3. So, or you can write x is less than or equal to 3. Now for the range, we're going up and down for y. We start here, and then we go up, and we can go up infinitely high. So for the range, we get 0 as our minimum value. Right here, and then no max value. Okay, makes sense? I hope so. All right, an example with rational functions. Please try and solve this on your own. See if you can get the correct answer. Did you get it right? All right, so with x in the denominator, oops, I want to use red here, we have to ensure that we do not get a divide by 0 answer. That's undefined. So 5 divided by 0 is illegal. We cannot get it. And it's not a matter of it's not a real number. It's just an illegal operation. We can't divide by 0. So we have to ensure that the denominator, there's no values for x that will make that denominator 0. And this is a pretty simple procedure. All you do is you treat this as if it's an equal sign, add 3 to both sides. So x cannot be equal to 3. And then when we write our domain, really the easiest way to do it is to use all real numbers except x cannot be equal to 3. That's the only exception. And if we look at the graph, so, you know, as we go, we can go infinitely on our longer x line, infinitely to the left, infinitely to the right. But here, and this goes up by 2s, I think. So this is 3, 2, 4, 6, 8. Yep, so this is 3. And there is an invisible barrier here. As x gets closer to 3, we get infinitely large values because we're dividing by a fraction. But just like I said before, the domain, it can be absolutely anything with the exception of that one value. And now for range, it's really easiest to look at it with the graph. So, you know, we're going up and down now. So we're going to go up and down. This is fine. It goes infinitely large. It goes infinitely small. But there is a break here. You see there's this kind of invisible boundary. So there is no place where y is 0. And if you think about it, how are you going to get 0? The only way to get 0 is to have 0 over some number. And this is always going to be 5. Now this is going to be infinitely small. You're going to get 5 divided by a billion, 5 divided by negative trillion, but still it never will be true 0. So the range, just by looking at the graph or just by using common sense, we know it's all real numbers, but y will never, ever manage to get to 0. It'll be really close, 5 over the biggest number you can think of, but that's not true 0. All right, so last example is 2 over x squared plus 1. So we're going to do the same thing. We see x in the denominator, so I'm going to take the whole denominator and say it cannot be equal to 0. So x squared plus 1 cannot be equal to 0. I'm going to subtract 1 from both sides. X squared cannot be equal to negative 1. To solve for an x squared, I'm going to take the square root of both sides, and then look what happens. X cannot be plus or minus the square root of negative 1. Well, this is not a real number. It is a non-real answer, but we're just concerned about real numbers here. So there's actually no value, no real number for x that would make this denominator 0. So when we write our domain, it's just all real numbers. Notice we're not saying all numbers you can that exist, but it's all real numbers. And let's go to the graph. And you can see that as we move sideways when we're doing domain, we go this way, and that goes to positive infinity. We go this way, that goes off to negative infinity. There are no arrows there, but they're there. Because you can put in as big a number as you want. You can put in a billion, a trillion, quadrillion, whatever. You're going to get a super small number. It approaches 0, but it'll never be 0. It'll be 2 over a monster number. It's not true 0. And then as we go close to 0, it goes up, and then it gets to 2. When x is 0, you get 2 over 0 plus 1, which is 2 over 1, which is 2. So that's a point on the graph. So that's legal. So like I said before, the domain is all real numbers, but that is not true for the range. So when I do the range, we don't get any negative numbers. You know, you're squaring any negative numbers on the input, you're squaring so they become positive. So it stops here. We don't have anything, well, it looks like an X, but we don't have, there are no values here. Nothing down here. And then the biggest number we can actually get, as x gets bigger and bigger and bigger, or smaller and smaller and smaller, this approaches 0. The biggest this will ever be is here. When x is 0, we get 2. So it's, and this is a bit trickier. And really, to be really sure of this, you can do calculus, but you have to learn how to do calculus to know that that is the max value. But there are no tricks here, I promise. It's the range is just from 0, not including 0, to 2, and it includes 2. Now that's a little tricky. I wouldn't ask that question of you on an assessment, but I just wanted to show you a different kind of problem. So the range is not including the minimum value is 0, not including 0. And the max value is 2, and it does include 2. And if I wanted to do interval notation for the domain, remember we can just do curvy parenthesis negative infinity to positive infinity. And this is the max. Okay, I hope that was helpful. Thanks, guys, and I'll see you back in